Welcome to Spring Boot Lectures. As you guys went through the Java, now let's go to Spring Boot. Coming to the definition, what is Spring Boot? It is a open source Java based framework that simplifies the development of production ready, standalone, highly customizable Spring applications. From the definition, we will get to know it is a Java based framework. It is a framework and also it simplifies the development and it is highly customizable. So now we'll have the question, why a framework, right? Framework has lots of advantages. Now when you are building an application through just Java, it has so many features, but still you had to write so many boilerplate codes and other things. Whenever you are building an enterprise level application, you should only concentrate on business logic rather than concentrating on boilerplate loads, basic cross-cutting concerns such as security, logging, configurations, batch processing, scheduling. Framework also improves efficiency, consistency, productivity, scalability, maintenance, and also security. With this framework, our life as a Java developer becomes easy. Directly implementing all this through Java itself would take a hell lot of time and it also burns our peaceful mind. So that is why there is a framework development. Coming to the advantages, logging, security, dependency injection, scheduling, batch processing, all these are made easy through Spring Boot. And also it is called as frameworks of framework, meaning whenever there is a new library implementation, it will be possible through Spring Boot. So it is called as frameworks of framework. Next, we'll move on to features. What are the features that makes Spring Boot so efficient? Spring Boot has something called as inversion of control. In regular Java application, the flow is maintained from the application. So the object creation, destroying them, garbage collection, all these are function which is performed by the application. So the application will have control over the objects. Now in Spring Boot what we'll do, we'll tell the framework take our objects, control them and give us the object whenever we require. So we are giving the control to framework. Taking an example, if we have thousands of or sorry, thousands of objects in a enterprise based application, we need to manually create the object, destroy them, garbage collect it. So it is a tedious job. So all these things are taken care by Spring Boot through inversion of control. This is achieved through dependency injection. Moving on to dependency injection, we will have to know something called as Java Bean. Java Bean is a reusable software component that follows specific conventions regarding its construction, properties, and behavior. We'll go to our Eclipse and see what is this Java Bean, right? So we have this basic student class. We will define some properties such as name, name of the student. We will define age of him, let int age. So Java Bean has a properties which are accessible through modifiers. So these modifiers are called as getters and setters. So in your computer, hit Alt Shift S and go to generate getter setters and select them. Now it also should have a constructor. We will generate a constructor. Java Bean should have a property which are accessible through only getters and setters, and properties are typically private and accessed through these getters and setters. It should have a default constructor with no arguments. This name property can only be accessed through getName and can only be set through setName. So this is a basic Java Bean. Next, moving on to dependency injection, we are creating these classes, right? We tell the Spring that these classes will be given to you, take them, and you provide us whenever we require. What it will do is it will create a reference graph and it will know. Now in example in the student we can also have something called as a student class subject class. In the subject class we can have private string subject name and this can be, you can also create getters setters and also the constructor required. Select all, generate. Now you will create a constructor through this. So now you have this subject. If you want to add one more property called as subject. Now in regular Java, what we used to do is we will do equal to new subject, right? Then only we can access the subject through the constructor. So if you have thousands, can you do all this? And if there is a relationship, can you do all this? Even if you can do this, in this scenario, the student is dependent on subject object. So whenever you want to create a student object, you need to have a subject object created already. So this leads to a tightly coupled system. Tightly coupled system will have dependency. Whenever you have some dependency and it is, so now you can't create a student object without subject. So this is depending on the subject object. So that is why we should go from tightly coupled to loosely coupled by injecting the objects whenever it is required. Meaning, whenever we want student without subject, we should be able to create it. Whenever we have a subject, let it come. Or else we are just concerned to create student object as a separate entity, subject object as a separate thing. So this is how the dependency injection is being made. You have many types of dependency injection, which is construction based, XML based, annotation based, Java configuration based. We will be looking into annotation based in our coming lectures. Now, coming to other features of Spring Boot, that is aspect oriented programming. You know that the boilerplate code is all this and all these get XML configurations which is there, and the basic cost cutting concerns such as security logging configurations, batch processing, scheduling, all these methods should be handled. But as a developer, we don't have so much time. What we do is we group all these in a separate method and keep it. Whenever we are doing a transaction or we are performing some actions, we call this method to take care all of this cross-cutting concerns. So this is what is aspect oriented programming. Other features which is it is ability to create a web application through Spring MVC. It can easily be connected to database. If we are working in a Java, we know that we have something called as JDBC to connect with the database. So it is a tedious process, right? So the Java Spring Boot provides various libraries which will provide connection to the database, regardless of what it is, whether it is a SQL, MySQL, NoSQL, or Oracle. It has libraries for all these things. As we know, it can implement all these libraries through Spring Boot. It is called as frameworks of framework, as I already mentioned. One more important thing of doing all this is to test our code component based. Each piece of code should be tested by itself. So this method will also simplifies that. Next, we have something called as dependency injection, right? In that we have something called as interfaces which are bean factory and application context. From this, we can all get the beans which are there in the system and use it. That's all in this lecture. We will continue the setup in the next lecture. Thank you. Are the features, advantages of Spring Boot. It also includes rapid application development, managing dependencies, auto configuration, embedded servers. So, what are the softwares required for the setup? So, we will be using the Eclipse IDE throughout the lectures, and we need JDK 17 and also Workbench, SQL Workbench for our project. And we also need Postman to test our APIs. Let's start creating a Spring Boot project through Spring Initializer. We will go to our Chrome and type URL as start.spring.io. In the Spring Initializer, we will choose project type as Maven, language as Java, Spring Boot version 3.2.2, and we'll give group as com.galaxy. This would give a unique ID to your project, and Spring artifact as Spring Boot tutorial, name as Spring Boot tutorial, and description, whatever description you want to give to your project, you can give. I will leave as it is. package name would be com.galaxy.springboard tutorial. Now we will give tutorial Galaxy Spring Boot tutorial, and we package it as jar file and we'll select JDK 17. Now it's time to add dependencies. We will add dependencies. First is web, Spring Web. One more is JPA Spring, data JPA. One more is Spring Data JDBC. Now here you have an option to share this to your friends or anyone who want to use the setup. Now we'll generate this. It is there in our download. We will extract it to our desktop. We have a Spring Boot tutorial and we will select this. We will select this and extract there. Now I will show you how to import this particular project which we created through Spring Initializer. So in your IDE, go to File, open Project, File, File, Import, Exist under Maven, existing Maven project, browse. You go to Desktop, Spring Boot Tutorial, Galaxy Spring Boot Tutorial and select folder. So it found a POM, so it is a Spring Boot application, then finish. So you have Galaxy Spring Boot tutorial. So now we understood how to create a project. If you remember, we selected it as Maven. What is Maven? It's a software project that follows Maven project structure and it utilizes the Maven build tool for managing dependencies, building the project, and handling other project related tasks. Maven is widely used for building automation and project management and also simplifies the build process and project management during Java development. So it has something called as POM.xml. The POM refers to the project object model file. This defines all the configurations, dependencies, and plugins which are present. I said Maven is a build tool. Build tool, why it is required? Build tool is essential for the process of building. Building in the sense we should generate the source code, generate documentation for the source code, then compiling of the source code, then packaging this compiled code into the jar file. Later, installing these packages on the local repositories, servers, and central repositories. Maven is also written through Java or C Sharp. It is based on project object model. When we are executing the application, Maven searches for the pom.xml in the current directory. Then, coming to the need of Maven, it helps downloading all the dependencies which refers to the libraries or jar files. Before Maven, people used to download all the jar files searching for a particular version, and it was a tedious job. Now Maven is there for us. And then what is the other need is right project structure. The project structure here you can see under the Galaxy Spring Boot tutorial you have source main Java which has com.galaxy.galaxy Spring Boot tutorial. Under this you have Galaxy Spring Boot tutorial application. So you have main application under this folder structure. Then you have source main resources. Under this you have static which will include your front end code. It can be through React. Templates will hold all the templates and application properties which are the properties of your application can be defined. And you also have a test folder where you can write all the JUnits, all the test cases here. This is the Maven folder structure, and you have all the JRE system libraries and whatever dependencies required will be stored under Maven dependency. And last you have something called as pom.xml. Pom.xml will have this part of pom.xml contains all the metadata which is your artifact ID, group ID, what is the version, what is the name of your project, what was the purpose of having this project, all the things. And then you have the dependency list. Whatever dependencies we selected or whatever dependency we want in future, we will be adding inside our dependencies. So all the dependencies which are mentioned in the pom.xml, these jars related to these will be downloaded automatically. If you have other application which has to be linked to this particular project, then you can add the dependency here, and that is also known as transitive dependency. Now we took Lambok as a dependency. We can add Lambok as a dependency that is a Java library that helps us to reduce boilerplate code, and it also achieves this by providing annotations that can be processed during compilation. It automatically generates codes like getters, setters, equals, and many more. It has annotations like at the rate getter, at the rate setter, at the rate toString, at the rate no args constructor, at the rate all arg constructors, at the rate required args constructor. And also we have at the rate data and at the rate builder. And we can also download the dependency and add it in the pom.xml, which is MySQL connector Java. It is a driver for connecting Java application to MySQL database. These are the packages which dependencies which can be added. So if you go to the Spring Initializer and if you type MySQL driver, JDBC driver and explore, you will get the code here you can have this dependency. You can copy this and paste in our dependency. So now we know how to add dependency, how to download a Spring application from the Spring Starter. Now we will see how to create a Spring Boot application through Eclipse IDE. So we are in the IDE. Now what we will be doing is go to File, New, Project, Spring Starter Project. Next you have this, it is getting the project from start.spring.io. I will give the project name as Galaxy application. We will keep it as Maven and 17. This, let it be group ID as com.galaxy, and we have artifact, which is the name of our project. Snapshot, what is a snapshot and what is the purpose, what is the description, and you have a package name, you have packaging as jar, language as Java. So now we will click on to next. We can add dependencies required. So I will add Lombok, which then MySQL driver, Spring Web, Spring Data JPA, and Spring Dev Tools. So these are the dependencies that I will be adding to my application. Then click on finish. So you have Galaxy application present. Since we added the JDBC, we need to connect to the database. So here I am in the MySQL workbench and I have database called as Spring Boot, Galaxy Spring Boot training, and it has no tables, it has just started. Now I will be configuring it inside the application.properties file. First property you can give as server.port equal to 1990. Next, to have the database connectivity, we will have these configurations. So here we can add the database name, which is Galaxy Spring Boot Training. Galaxy Spring Boot Training. Okay. You can provide username, password, and then Spring Boot data source URL. So you can provide the database name and other features which I will be explaining later. And then you have the driver class name, which is JDBC driver, and this is the port number. Now we will run our application. To run our application, first we'll do Maven update project, select the project, force update the snapshots and releases, and click on OK. So this will give all the jar files which are required for the dependencies present in pom.xml and put it into a Maven dependency folder. Then what we'll do, we'll do a build path. We'll select Maven dependency and JRE, apply and close. And then we need to run as build the project, which is we can clean it and install. Since we don't have any test case, we are skipping the test cases and apply and run. So build success. Now you will run this application as Spring Boot application. Okay, there might be some problem with the database. So we'll go to the application.properties folder. So in the application.properties file, we kept 1990. And the error was saying that the port is already used. So what we'll do, we will keep it in 1991 and we will maven build it once again, maven update it and then run as Spring Boot app. Okay, this says started the Galaxy application in 0.527 seconds. So it also started the server on 1990. So this started our application and now here we can see that we are running the application. Just in few seconds you can do all this using Spring Boot. Such a easy thing, right? So this is all on the basic starting with the Spring Boot application. In the coming videos, we will build a RESTful service that is, we'll build APIs to get something from the database, modify to the database, add to database, and also delete from the database. So all these things we'll build in the further lectures. Thank you for patiently listening to the lecture. Welcome to Spring Boot Lectures. In the previous lecture, we saw how to create a Spring Boot application through Initializer as well as through Eclipse IDE. So now we will look into important topics to build our REST APIs. So in the REST API, so you have a request, API request made. API request made and then it goes to a layer called as presentation layer. Presentation layer is also called as controller. So it consumes the API request through REST APIs and then it passes the control to service layer. So service layer is where we have all the business logics which are written and then we'll go to the data layer and we will then connect to the database. In our lectures, we will be using MySQL database. And then after getting the data from the MySQL, what will happen? It will give the data to the data layer, then it goes to the service layer, then it goes to the controller. Through controller, it goes to the whatever API it requested to the service it goes. Now, let's go to our IDE. So, in the IDE, we see this Spring Boot application at the rate Spring Boot application. What is this all about? Let's go inside Spring Boot application. So here you can see some three important annotation which are Spring Boot configuration, enable auto configuration and component scan. So the Spring Boot configuration internally uses the at the rate component configuration. So at the rate configuration, it is used to provide configuration as a Java based configuration. You can configure either as a XML based or a Java based or annotation based. So you can create some class and annotate it as at the rate Spring Boot configuration or at the rate configuration to act that particular class as a Java based configuration. Then we have something called as enable auto configuration. Enable auto configuration whenever we have a Spring Starter web dependency in the class path, we can enable auto configuration in all the classes. Then you have something called as component scan. It will scan the entire application inside to get all the packages and to get all the component inside the base package as well as the sub packages. So these are the three annotation which we have: Spring Boot configuration, enable auto configuration, and component scan, which are important to make our Spring Boot application. This enables our Spring application to look into all the components and have it in a container, and also we can enable the auto configuration, and we can make it either as a Java configuration or a XML based or annotation based. So this is all about the Java application, which is a Spring Boot application. Now we will see how to deploy this particular structure, the controller layer, service layer, and the data layer. So we will go to our IDE. Now from this com.galaxy, we will create a package called as controller. Finish. And then you can create one more package as service. You can create one more package as service galaxy dot service impl. Service impl. Finish. And then we will have something called as, to hold all the entities, we will have one more package called dot entities, and then we can have package called as DAO. Finish. Okay, coming to your base thing, which is a data layer. So for that, we will create a new class called as student. We will remove the constructor. Now, student will have three attributes. We will keep them as private: int student ID, then private string student first name, private string student name, private int age, student age. So these are the properties that a class has. So I mentioned in our previous lectures that we have something called as Java bean. So to have it as a Java bean, we want getters and setters. So getters and setters we can define either like this, by generating the boilerplate code, or by just annotating it with @ getter at the rate setter at the rate no args constructor at the rate all args constructor at the rate toString. So all these things will do the same job. Getter setters will generate getter setters method. No args constructor will give you constructor without arguments. All args constructor will give you the constructor with all the arguments, and toString method will generate the toString method. So instead of doing all this, you can also do as at the rate data. So so you know that Spring has something called as dependency injection and inversion of control. Inversion of control, when you give the control to the Spring framework itself to manage all the object creation and deletion of them, garbage collecting, all the things to it. It is inversion of control, and you have these beans created and stored inside the Spring container, which can be application context, which is an interface. Now, for it to Spring Framework to know that this is a particular class or a entity that is connected to the database, we have something called as at the rate entity. Entity, it will mark the Java class as an entity, which is typically represented as a table inside relational database. So, in this context, what happens is the JPA, it will define it as a persistent entity, meaning instance of this class can be stored in a database. So it will tell that whatever instance we get from this particular class can be stored inside the database. So it is declared, the at the rate entity is declared that instance of this class will be managed by JPA and also can be stored inside the database. You have something called as at the rate table. At the rate table specifies the details of that database table that will be mapped to this particular entity. You can customize various aspects of the table, such as name. You can give a name to it as a student. Sorry, student. What happened? Student. Okay. And other things like indexes and unique constraints all can be specified to this at the rate table annotation. So now we have entity and we define it as student table. Now every table will have a primary key. Is it or not? Primary key is very important. So to indicate this particular thing is a primary key, we will define this as ID. At the rate ID indicates that primary key of this entity will be this particular property. And we have something called as generated value. Generated value specifies how the primary key should be generated for the entity. So we can give the strategy for it. We can define a strategy for it called as we have generated type. You have auto, identity, table, sequence and none. Identity in the sense it has auto increment for the column in the database. Sequence is when you have a sequence followed in the database. Then you have table. You will have a separate table to maintain all these current value of primary key. And auto will have all these identity, sequence, table, everything, and it will choose whatever is uh, applicable for the database that you are using. And we have none. Now we will use identity as our generated type. So this is all about your entity class, and we will see how to connect this to the controller and the service layer in the later sessions. Thank you. Welcome to Spring Boot Lectures. In this video, we will go through controller and service to link to our database. Let's go to IDE. In our controller package, we will create a new class called as student controller. Let's create one more service inside the service file, which is student service. So here student service is an interface. Then we'll go inside the service IMPL and create one more class, which is student service IMPL. This implements student service. So you have your controller, service IMPL. For the Spring framework to know that this is the controller or this identify this component, we have to provide something, right? That is nothing but a @rest controller. What is @rest controller? It is combination of controller plus @response body. Controller, this REST controller is useful for creating RESTful web services. This indicates that the method within this class are designed to handle HTTP requests and produce the response directly, typically in the format of JSON or XML. This is the function of the REST controller. Next, we have something called as request mapping. @request mapping. So what is this request mapping? It is used to map the URL path to the controller method. In the simple terms, it is like a signpost that tells your application which Java method should handle a particular web address. It helps your program to understand where to go and what to do. We can give student. So you guys know what is REST controller and REST mapping. Now what we'll do, we will create a method which will post something, which will save something to the database. So what we'll do, and we also have something called as cross origin. What is cross origin? Cross origin. It is like telling your browser that it's okay for this particular part of website get data from other websites. So we are allowing data from other website to be accessed within this service. So it provides a convenient way to map the HTTP methods to specific methods in the controller. Now you have you can give star, so it tells that it is a global, whatever service you want it can be accepted. Now we can define a method. Public first will send string, get students method, and we will return hello. At the rate get mapping. So these things, get mapping, post mapping, put mapping, and delete mapping, these annotation provides a convenient way to map HTTP methods to specific methods in the controller. Now the get mapping will handle the get request. So get will give slash get students. We will hit this particular URL from Postman. Go to your Postman. You have a get method. So now I already have the URL, which is http 1991, we changed it, right? Members, instead of members you have a student get student. Now send the request. It is telling not found. We'll see on which particular port this application is running. It is running on 1991. 1991 is correct. And then you have in the controller, you have student, you have get students. So send. So now you are able to get hello from the controller. So now this is the get method. Now what we'll do is we will write a method which will accept student entity from the student details from the API request and saves to database. So we will define that method. Now anyway we have student class which has student ID, first name, last name, and student age. Student identity will be your primary key, so you have it auto generated. Now you also have something called as column, which will actually give the details of the columns in the database table. You can specify name. You can give specific name of the database column and map to the particular entity property in the class. And then you can define whether it is nullable, whether it can have a null values or not, length property which specify the length of the string, unique property which will give whether the column must have a unique constraint across all the rows in the table. All this can be given through this. So name equal to student, we will give the same thing, student first name, same we will put for all the things, student last name, student age. Now create one class inside DAO, new class called as student request. Finish, and it will have student, okay, it will have all these things. C, control V, and you have this column control D, control D. You don't want all those things. And you will have 2, control shift O, and you will give all the getters and setters. Getter, the rate setter. Okay. So now this is the student request, this is the student, and then inside the service we will have one method which is known as private. It will return, okay, we will create one more class called as student response. Finish. It will also be similar to this. At the data. At the data, and you have to mention component. Given on this particular thing. At the component. Now coming to your service, your interface. This will return student response save student. It will take student request, student request, student request. This is the same method. Okay, 1 second. New, we will create one more interface. Student service enter. Okay. Refactor, rename it as now. Here we should annotate with service so that the container can be formed. And we will write private student response save student taking student request, student request. Now what we'll do, we'll go to the student service IMPL. We will implement, give the option, add unimplemented methods. Now, whatever we have from the student request, we need a student, we want student. Since we require the bean here, we will annotate this with auto-wired, at the rate auto-wired. What is at the rate auto-wired? It is used for automatic dependency injection in the Spring. That means your student is an entity being there in the container. We will tell, give me the student bean here. So by telling at the rate auto-wired, you will tell the Spring container to provide me the student whenever it is required. It makes a This annotation at the rate auto-wired makes a constructor or field or a method as a auto-wired by Spring dependency injection facility. Now what we do is, now we are saving a student. Now from the student response, student dot set, so student dot set first name equal to student response dot get student response dot get request dot get student first name. In the similar manner, student dot set last name, student request dot get last name, and then student dot set student age. Next you have student request dot get age. So now you have all this, but you need something to save, right? Save it to database. So for that we have something called as repositories. We will create one more package called as dot repositories. Inside the repository, you will go tell new interface student repositories interface called as student repository. So this will extend JPA a repository, and it will take two things. One is the entity student, and what is the type of primary key? It is an int. ID is int. We give it as integer. Now inside the IMPL, what we'll do, we will call this repository student repository student repository, and we need to hardwire it. In our repository, we need to annotate it with @repository. Inside service IMPL, what we'll do, student repository dot save the entity student. So we have the response, we saved it inside, and then we are saving it here, and we are returning the same thing to the front end. Now we will see the controller. Student controller. We have it here. Student controller. We will define a save method. Public. We have something called as response entity. Response entity. What does this response entity mean? It represents the entire HTTP response. So we can give the status code, header, response body. It allows us to set the status code of the response. It allows us to customly change the headers of the response. It allows us to set the body of the response. This represents the entire HTTP request. So here we will send student student save students @post mapping, and we have slash save student. Here we will take something called as request body. Request body student response, then request student request. Inside this, what we'll do, we will call the service. To call the service, we should auto-wire it. Student service, and will the rate auto-wired, and we'll do student service dot save student request. Student equal to return response entity of student comma http dot request http response http status dot okay. New response entity. So now we have the save method written end to end. So what we'll do, we will go to our Postman, add request. We will take this, put it here. Instead of this, we will write save student, and we'll go to body and give it as raw JSON. And what is your response request? You will copy this, paste it here. First name is Kavya. Srinivasa. Ages 34. You have this as post method, and now can we hit the service? Yes, right? Will it do? Not. Your application should be up and running. And one more thing was, you You are not supposed to auto-wire a student here. You can do as student equal to new student. This is because we are not, we know when we require the student, right? That is why you have, so now we'll see whether we can post. This is post request internal server error. Why it is internal? Invalid data access, usage could not execute and doesn't exist. Insert into. Okay, we don't have a table in the database. Let's create that. We can add this Spring JPA Hibernate DDL auto. So whenever there is no table in the database, it will create automatically. Let's see whether it works now. So you can see that first entry has been done. So let's take one more. Multiply 25, send. Okay, you got to know, like second entry is also been made. We'll go to the tables here, create refresh all. You can see that inside the database, when we execute this select query, we can see that we have two entries, that is Kavya and Mayu. So this is how we can save the data from the API request till the database. So in the further videos, we'll see how to put, delete and get all the entries. Thank you. Welcome to Spring Boot Lectures. In the previous lecture, we saw how to save a entry into the database. Now we'll write a method to access all the details from the database and give it to the API requested. Let's go to the IDE. Here we can see that we have get students, but we were returning only hello. Let's modify it. Let's return a request entity which is list of string. So now what we'll do, we will write a list of students, as students, which will be returned from our student service dot get students, which will get all the students. Now we will give the same response, which is list of student and new student response entity. Now what we'll do, we'll create this method and we'll go to IMPL. We will add unimplemented methods. Now we'll do just one call. What is that? we'll just do one call, which is student repository dot get find all list of students. This is the method. So let's go to our Postman. We have a get method. Get. It is a get students. Get students method. Send. Here we can see there is two entry. So Kavya, Srinivasa and Mayurpai. If you go to the database, here if you execute this particular statement, you can see there are two entries, Kavya and Mayurpai. This is how you get a list of students. Now we will do one more thing, that is we will go to our controller. We will define one method called as put mapping to update the put mapping update student update student method name also update student. We will write update student. We will add all the unimplemented methods here. First we will do student equal to student repository dot find by id will find by name, first name. So for this we'll go to student repository. We will create a method public student find by student first name. It will take string student first name. We will define this method here. We will send student request dot get. It is a student request dot get first name student dot update set if student student is not equal to null. We will do dot set student last name student repository dot student request dot get last name, and we will have same for age, and then we'll do student return student repository dot save student, or else call save student of student request. You can remove this. Return. Now this is the update method. So we'll write that. We will copy the save. We will add request. We update student. Put and give the request body. So we will change Mayur Pi and send. So we got it. So in the database we had this one. We'll update. It came to Mayur Pi. Now we have one more thing. We can change the age as 26. Send. We can go to get method and get, you see the 26. So this is for update. Till now we saw save, get, update. We will do one more, which is delete. We will do delete student. Delete student will be based on first name. Student first name. So whenever you are taking it from a path, you will define it as path variable. So you will tell it as student first name, and what is it? String student first name. And here you will tell delete student, and you send the student first name, and it is not a student here. Now it will be a string. We will get it as a student, and then we will take it as first name, and we'll create this method, create method, and then in IMPL where is IMPL? In the service IMPL, we will implement unimplemented methods, and here we want to delete, right? So for that we'll do one thing, we'll copy Control Z. We will do first, we'll do student equal to student repository dot find by student first name, and then we'll do student repository dot delete student. If the student is not equal to null, then we'll do this, or else we will return student itself, or else return null. So we implemented it. We'll go, we will add new request which will delete. Inside the controller we should have at the rate delete mapping. So delete student, slash first name, send. So this is the entity which you are deleting. It is deleted. Let's see whether it is deleted. Go to get method and send the request. So you have only one entity, which you can also see inside this, only one entity. So this is the delete method. Thank you for watching. In the next video we will do get by first name, get by ID, get by last name. All these functions we will see in the next video. Welcome to Spring Boot lectures. In the last lecture we saw the delete functionality, get functionality, put functionality, that is to update, delete and get all the records from the database. Now in this video we will see how to get, like if we have some filter, we can get by first name, get by last name, get by age. So we will create these methods in a easy way. Let's copy this, paste, and get students by first name, students by first name, slash student first name at the rate path variable student first name string student first name. So students by first name pass this particular student first name, and we'll go here and create, and then in IMPL add unimplemented methods. You can have it is a student. So the service also. You have okay. Sending only the student. Here first name and last name are unique. First name is unique, so we have only a student. So we will remove this student, students. So this should work, right? So we will go to our postman. You can add new request, add request, control V, control V, like control C. We will get students by what was the controller path first name to V slash Mayur. Will we get now? We got right. Get by first name. We will do one more method called as get by age. In the similar way, we will have get all students by their age, by student age and age, students by age. Get students by age. Age will be a number. So we will get it as, we will copy it, paste it here. It is a int student age. Control Z, Control V, paste it. So we'll go create method, save it in the service IMPL. We will implement unimplemented methods. We will go to repository. We'll write a method which is called as get by student age. Age int student age list of student. In the service IMPL, we will go to this method. We will call student repository dot get find by student age. We will go to Postman. We will add request. Did we change the controller? We have get by student age. Age we will give 26. Send. We have get by age. So these are the things which were important for filtering and all those things. So let's meet in the next video seeing one-to-one mapping and many-to-one mapping. Thank you. Welcome to Spring Boot Lectures. In this lecture, we will be talking about mapping. We have one-to-one mapping. What is this one-to-one mapping? So this one-to-one mapping is a notation used to establish one-to-one relationship between the two entities. So this implies that the record in each entity is associated with exactly one record in the other entity and vice versa. So if you have a student entity and you have one more laptop entity, if each record in the student has only one record in the laptop, then it is called as one-to-one relationship. In this also you have two types. One is unidirectional and one more is bidirectional. Unidirectional in the sense if the entity student knows about the other entity laptop, but this laptop is not aware that there is one entity called as student. So one entity knows about the other, but the other entity is not aware of this relationship. This is called unidirectional relationship. Let's go with the bidirectional relationship. It is when both entities are aware of each other and have reference to each other. So this is bidirectional. So now let's go to IDE and start coding. We'll create one more entity called as laptop. We will have two attributes in the laptop. One is the laptop model. One more is the laptop name. So to know the string that this is an entity, we need to annotate it with @entity. And then we have getters and setters, @getter, @setter, no args constructor, all args constructor, @data if you want. And then you can also mention the table name by giving table name is equals to laptop, and each entity will have a primary key which is annotated with @id, and we should specify the generated generated value as strategy is equals to generated type dot identity. And then we can also specify the column attribute. We will specify it. Name is equals to, what is the name? Laptop model. We will tell it as laptop model number. Instead of all this, we'll just the laptop model number and model name. Then we keep this here. So we successfully created the laptop entity. So now we need to connect this to the student entity with 1-to-1 mapping. What we'll do is we'll write private laptop and then we will tell it as 1-to-1 mapping, 1-to-1 mapping, and then this is a unidirectional. So your student class knows that there is a entity laptop which exists, and it also knows there is a relationship which is 1-to-1 between these two. To make it a bidirectional, what we'll do is we will have the student entity related here by telling @1-to-1. So to make it bidirectional, we should also give map it by property with the whatever we are mapping in the student. So here we are mapping the student to a laptop. Correct, no? We are mapping it to a laptop. Then here in the student entity, we need to have a cascade property. What is this cascade property all about? Cascade property is like the attribute which defines the cascade operation which is applied throughout the association of entity. When a change is made in the entity, say the delete, create, update or refresh, whether it should be cascaded to the child entity or not. This has to be specified externally. That you can give it by telling cascade equal to cascade type dot all. So we are taking everything into consideration. Apart from this, we have some other attributes like fetch attribute. Fetch attributes will define the fetching strategy. Like it can be either lazy or eager. Lazy in the sense whenever you are getting the parent component in the first call, should I go get the child properties also, child entity also. So if it is lazy, it won't bother to get the child. If it is eager, it will get the child entity as well. So this is the fetch attribute. You have one more attribute as optional, which indicates whether the association is optional or mandatory. This is a Boolean value. Then you have something called as target entity. So it allows to specify the target entity class when dealing with bidirectional relationship. Then we also have one more property attribute called as orphan removal. It specifies whether to remove the association entity if it is removed from the association. These are the attributes which can be given to one-to-one or one-to-many. So now we did this. Association is done. So now to save this, we need to add it to our request. So in our request, we will add private private laptop laptop laptop, and then we need to save this in while saving student. We should also set the laptop entity. So we go here, we take student dot set laptop student request dot get laptop. So this is done. So we created laptop entity, we mapped it to the student, and then here in student also we mapped. So this becomes bidirectional, and in the service layer we also set the laptop property. So let's go to our postman. In the post method, we had these three property, which are student first name, last name, age. Now we also added laptop, right? So laptop property, we also added it. So what we'll do, comma, laptop. This is an object. So in the laptop, whatever we have, model number, model name. Model number can be any CK B08 BH78, some number, and model name Lenovo ThinkPad. So we'll send the request. We got the request. So here we have the student property as null. So to stop this propagation, what we'll do is go to our entity. In the laptop class, we have something called as JSON back reference. So this will avoid looping whenever we have sequencing, um, sequencing or serialization. So to stop that propagation, we have JSON back reference. So we will change the name. We will post one more, and then in the get request, we'll go send the request. Here you should also give join column name equal to whatever ID from the other entity, primary key. Can also give referenced column name as top ID. So we go to the get URL and we can see that we have a record which is there. So we will post one more record. You can see two records. So this is how you can do one-to-one mapping.